Okay, so I have the same setup as in my other assignments. The only difference is I now actually have a folder for once. A little more annoying. I actually don't like doing it this way, but I guess it's technically better. That just means that I now have to go to it every time I run this, which is kind of annoying, but assignment 5. Okay, GCC assign 5.c, and we're going to call it the same thing I've been calling it. Okay, so this assignment contains two files, assign5.c, the C file containing all of the code, and num.txt. This is just a txt file with a bunch of integers in it. So when we run the code, we need to specify that num.txt is the name of the file that we're accessing, because the code does not tell it that anywhere. So we're going to give it num.txt, and then additionally, we need to tell it how many memory slots we are going to give it. So let's just say 4, and I'll explain what that means. My bad. Assign 5. There we go. Okay, so for first in, first out FIFO, we have 6 page faults. Same with our LRU, least recently used, 6 page faults. And the final state of memory is 5, 6, 3, 4 for both of them. So the reason why they're exactly the same for both of these is because in num.txt, we have no repeating numbers, which typically, if you don't have any repeating numbers, it's going to be the same. There are some scenarios where even if you have repeating numbers, it could still be the same. So like, for example, if I switch this 6 over to a 3, we're going to have 2 3s. But if I were to run this, you would notice it still gives us the same numbers. And this isn't just because I didn't recompile it. You don't need to recompile it because it's just the num file being changed here. So you can see the numbers are the same even when we have repeating numbers. And so the reason for this is because the way that this works is if we have 4 memory slots, what that means is the program is going to look inside this txt file, and it's going to grab the first 4 numbers, and this is all the memory that it has, only enough for 4 numbers. So this 5 and 3 are not in here, and it's going to have to take something out of this. It's going to have to replace it in order for the rest of the numbers to finish. So we start with 1, 2, 3, 4, and with first in, first out, it's going to look at that first in, which is the 1. It was the first number added, and it's going to be the first one out. So 5 will go into that 1 slot, and then 2 is the next one that is that needs to be expelled. So it will become 5, 3, 3, 4. 5, 2, 3, 4. Hang on, let me see. You have these 4. 5 goes into here. 3 goes into here. 5. Oh, that's right. My bad. There are 2 3s. So it'll be 5, and then this 3 will not get added because there's already a 3 in memory, and so it's not going to add that. So it'll just be 5, 2, 3, 4. The only number that changes in this case is the 5. And in LRU, it's going to be the exact same thing for that same reason, because the way that LRU works is it looks at the first one, the first number added, and it actually, instead of focusing on the first number added, it looks at the least recently used. So 3 actually gets used twice. Once we get to the 3 part of it, it gets used twice, and so it actually goes back to the back of the list. You can't really see that in this example too well because it's so short. But if I were to add more numbers here, and a lot of repeating numbers, what's going to happen is it's going to go through each of these 4 at a time, and it'll add 5. Once it gets to the 3, it'll already have 3 in there. Once it goes to 4, it already has 4 in there. But it's different from first in, first out, because first in, first out doesn't care about these repeating numbers. It won't skip over it like it will with LRU. And so because we have so many more repeating numbers, this time it should look differently. As you can see, 1732 and 1376. We now have different ending numbers. The number of page faults has also gone up. Obviously, anytime you're adding more numbers, generally the number of page faults is probably going to go up. Page faults go up when there is a number that gets added. So these first 4 numbers add 4 page faults. 5 will add another page fault, but then once you get to 3, it's not going to add a page fault because 3 is already in memory. So if it's in memory and it adds the number, it's not going to increase the number of page faults. So let's look at the code now. So here we have our code. At the top here, page index. This just searches for a page in the frames array. It returns the index number. If it's not found, then it'll be -1 by default. Then we have inside memory. Inside memory is a bool. It'll return true or false depending on whether or not one of the integers is already in memory. If it is in memory, then it returns true. If it's not, it returns false. We have the LRU function, which initially was giving me a lot of trouble because I had the loop running incorrectly, and it was actually adding the numbers in reverse. So if, for example, it was 1, 2, 3, 4, it would add it. It would add it from right to left, and that was resulting in the answers not being the same when no numbers were repeating, which I knew meant that there was some kind of bug somewhere, and that was the cause of it. So first in, first out's function, just very similar to the previous programming assignments we've done. Print memory just prints the memory in the array. Read page references. This opens the num.txt, I think I called it. It just reads the numbers, the integers from it. We have main. This just has some of the error handling, some of the print statements,